Hello everyone! In this video we will show you a simple example of how to implement the machine tending process in the Hyper application. We need to open the Machine Maker application to assemble the setup. We need to open the mechanism library and select the robot. We will also add a stand like this for it. To connect the robot to the stand, hold the left mouse button and the left control key. After this, the robot will connect to the stand. Next, we will add a tool with two ends. A simple table, and we also need to add a machine. Once you have assembled your project, to send it to Hyper, you need to click the Export button. When you click, the project will start opening in Hyper and Machine Maker will close automatically. After launching Hyper, you will see the Cell tab where you can add trays to your mechanisms. In this case, we will add a small tray to our table to place parts at this point, which we will add in the next tab. Also, don't forget about the machine. We usually add a single point to it, where the part will be inserted for processing. We will also add a second table. We can use the Add Object function for that. We will edit it according to our necessary parameters and move it to a convenient location. We will also add a tray to it and click the Apply button. After this, we will go to the Parts tab, where we will need to either import existing 3D models or an example. We will add an example of a cylinder with these parameters. We can also specify the gripping point for this part and edit the gripping depth as well. After applying, the part will appear and we can place it in our cell that we added earlier. For more convenient filling of cells, we can hold one of the points and add all points at once. The logic of our work will be that the robot will pick up unprocessed parts from the table with one grip. With the second grip, it will take the processed part, swap it for the unprocessed one, and return the processed part to the new second table. Next, we will go to the Programming tab. In this tab, all the main work happens, where you can add commands necessary for the machine tending process. Let's start with the pick command. It is needed to indicate to the robot where and which part to pick up. With this slider, we can tell the robot that it is working with multiple parts and set a strategy for more optimal operation. After setting the pick command to start, we will add another command. Also, pay attention. In this tab, you can change the grip number. In this case, the robot will take the second part with the first grip, and it will take the second part with the second grip. Thus, we will have two grips working. The next command is place, which will help us correctly position the parts. For the first place command, we set the location on the machine for inserting the unprocessed part. Next, another place command is needed so that the robot understands where to place the next parts it retrieved from processing. After you calculate your program, you will see that the trajectory has been drawn and it is not quite correct. The robot collides with the machine and the program itself is not looped, meaning it is incomplete. If we run the simulation, we see that the robot performs the actions we need, but after it completes these actions once, the process ends. To loop this process, we need to add an if condition to make the robot understand that if we started processing on the machine, it needs to go to the first action it had. Which is picking parts from this tray and go in a loop until the parts run out. After you edit the conditions, you need to recalculate the project, and you will see how your trajectory noticeably increases. For the completeness of this process, we also need to set up collision avoidance using the Save Path button. It enables a safe trajectory, but to turn it on, we need to enable this slider for each command. This will take some time, so we will have to wait a bit. After calculating the safe trajectory, you will see that your trajectory will be marked in a different color and will noticeably differ from the previous one. If we run the simulation, the robot will choose a safer trajectory and perform the work. So, essentially, with one click, we eliminate all collisions that could occur. Let's increase the speed. We also understand that processing a part does not happen instantly. For this, there is a pause command in the command list that we can add. In this case, it needs to be added after the first place command, when the robot swaps the prepared part for the unprocessed one. In this window, you can set the time. It is set in seconds. A delay, for example, a timer for 2 minutes or 1 minute. And your robot will stand for as long as you set in this window after placing the part. Thank you for your attention.